is the Workshop 3 video talk through part 4. We are now on step 10, so we had looked at our time series, and in order to try and reduce leakage, we multiplied our time series by a window, which is tapered, so this is the resulting time series. And now the step we need to take next is to recompute the power spectrum from the product and observe the difference. So we just want to have a look at how it differs. So if I open up, do I have a figure? No. So let's plot our power spectrum again, plot PSD, so we'll run it with our original time series, why not? Okay, so we've got figure 2 here, that's probably, we'll just get rid of figure 1 for the moment, and we'll just make a comparison between our original power spectrum using a non-windowed, just original time series, and then using, where's it gone? I probably overwrote it. Okay, let's plot, open up a new figure window now, and I'll just plot our new time series, which we're going to input to our function. Okay, so what we want to do then is to call the function again and generate another figure 2 for this time series. I'm just going to do this from the command line because we don't need to generate another script for this really. It's end up with too many little scripts doing lots of little things, and really we just want to have a look and see what the difference is. Okay, so we can run, and I'm just going to copy this call to our find PSD function, and we'll do it from the command line down here. Okay, and instead of putting in y naught, I'm going to put in y naught dot times w prime, and let's just call that PSD w and frequency w. Okay, so we don't overwrite the previous one. Okay, so that's, we've now got another power spectral density, and we're just trying to have a quick look really to see what the difference is with a what's the effect of multiplying the time series by a window, basically. Okay, so if we go back to, we want to generate another figure 2 basically. So if I effectively want this series of commands up here. And so what I'm going to do then is use the same, generate a new figure again, and use the same plot commands that we've got up here. So plot, actually let's just copy it. Plot, Control C, Control V. Okay, and instead of having, we want to zoom in again like we've done here, we might as well use the same axes limits. So I will just copy all of this actually, put it down here. Okay, so we're just having a look at the effective windowing. Oh, I know what we haven't done correctly here. Sorry, we've plotted the same one again. So plot frequency times 24, we don't want that, we want to plot frequency W and PSDYW. Okay. There. And then we want to change the axes limits, put the grid on as well. Okay, and now these two figures here are comparable now. The top one has got, is the power spectrum generated using our raw time series, artificial time series, and the figure 3, the bottom one, is generated by multiplying our time series by window functions, this function over here. Okay, so what you can see basically is that by tapering the ends, by removing that abrupt finish at the ends of the time series, you get spectral peaks which are much more pronounced over the background spectral noise, if you like, and you don't get as much leakage, so you don't have all this energy at other frequencies which are not in our time series. There still is some leakage, and if we were to change the time axis again, you'd see this. Sorry, the x y limits. But you can see that we have reduced the energy at other frequencies other than the periodic components that we're expecting to see, and made these peaks much more pronounced down here. Okay, so that's the effect of windowing. Now, we were just playing around with that just so I could illustrate what the effect of windowing is and how it changes the output for the spectrum. Now what I want to do next is to add a random component, but we'll do that in part